All right, thank you so much all for joining again. Recently, we have completed our first lecture at 7 past 10. So now this is going to be the second lecture. The first was for paper one, and we have gone through from teaching concepts like traditional based and modern based. In this video lecture, this subject is going to be, or the topic is going to be for skewness and kurtosis. Yesterday, we studied about measures of a central tendency. We went through from its basic and we took two lectures in which the first lecture in which we studied about some basic of data series, and next we did the measures of central tendency, basically mean, then median, then mode. After that we studied about geometric mean, then last one was harmonic mean. Now in this video, as has been prescribed in a very clear form that you have to study about skewness and kurtosis as well. This is why we are giving this lecture. And in this lecture, I shall make all your clear concepts regarding the terms of skewness and kurtosis, how to solve these. And before starting this lecture, again, as the convention is there, I would like a quick confirmation from you all. Is everything okay? Can you hear me? Am I audible to you? Navneet, Nisarga ma'am, can you please hear me completely? Salim sir, can you hear me? Is my voice audible? Is my module is okay? All right. All right. I have received confirmation from at least 4 to 5 students. Now I am just sharing my screen so that everything is visible to you. This is going to be very important from now. Okay. Because this topic being part of not only the paper 2 but for paper 1 as well. Okay, not for paper 2 but for paper 1 as well. This is important. Why? Because in the research methodology you have to go through from basics of data series, and when we talk about a data series we always talk about skewness and kurtosis as well. Okay, so let me see if okay, everything is being recorded right now. Okay, so now we shall study about skewness and kurtosis in detail. Okay, we have already understood about measures of central tendency. We have gone through from the concept of mean, then median, then mode, then geometric mean, then harmonic mean. Okay, so before going through all these, you have to recall everything which I have taught you yesterday. Okay, I taught you about a data series. Okay, you have to recall each and everything. There were three kind of basic series. The first was individual series, in which only one variable was given, and the next is discrete series, in which the variable was given but it had only discrete value. I mean the value which cannot be represented in fractions or decimals. And the last one was a continuous series. Okay, so these were the series, and I explained you about frequencies as well. Frequencies means for how many times a particular item is occurring, for how many times an item is occurring in the series. So this was the frequency of individual series. Only these things you have to keep in your mind, otherwise this topic is very easy. Okay, I shall teach you in a ways each and everything shall become very easy to you to understand. Okay, before showing you all these slides, I'm going to give a simple example to you all here so that you are able to understand this completely. Suppose a series has been given. This is 1, this is 2, item number 1. Suppose these are the values of x. X has 5 levels, 1, 2, 3, 4, 5, and their frequencies have been given. Frequency of 1 is 5, frequency of 2 is 10, then frequency of 3 is 15, then again 10, then again 5. And if we are plotting them, Okay, if we are plotting them, like if we are taking on the x-axis the items, okay, this is 1, this is 2, this is 3, this is 4, this is 5. 1, 2, 3, 4, 5. Okay, and on the y-axis we are writing their frequencies. Okay, we are writing their frequencies. So how can we write these? Like 5, then 10, then 15. How can we make the plot? One has, so here one has frequency of 5, so we can tick here. After that 2 has a frequency of 10, we can tick here. Then 3 has a frequency of 15, we can tick here. Okay, then 4 has a frequency of 10, we can again tick here. Then lastly 5 has a frequency of 5, so we can write it here. Okay, so if we make combination of all these dots and we make a distribution, this distribution is known as frequency distribution. This is known as a frequency distribution, and this is, from this you can understand the concept of all skewness and kurtosis very simply. And if, remember me, I'm going to tell very important line. Okay, if the frequency on either side, frequencies here and frequencies here, okay, frequencies here and frequencies there are equal, if frequencies on left hand side and frequencies on the right hand side for all the items are equal, then this concept or this curve becomes the normal distribution. Normal distribution. So this is the complete description of this. This is normal distribution, and in case of this series, mean is always equal to median, and this are always equal to mod. So mean, median and mod is always equal in case of these kind of series. So from this one example you can understand each and everything I have to represent to you in this specific video lecture. So what is there? Measures of skewness and kurtosis study the characteristics of a frequency distribution. Frequency distribution I have explained you completely. This is a frequency distribution, the curve coming from the left hand side and going to the right hand side. This is called frequency distribution. Okay. Then measures of dispersion tells us about concentration of items around the central value. Now, what is concentration? Concentration means where does they lie? 2 lies here. Okay, 1 lies here, 4 lies here, 5 lies here. Central value is this point. Okay, so measure of dispersion tells us where the item lies in relation to their central value. So this is, you have to understand. So what is skewness? Skewness is the measure that studies the degree and the direction of departure from symmetry. So I am writing here again the table, the frequency distribution table. Suppose the values of x have been given on the x-axis. This is x-axis, this is y-axis, and this is the central point. Okay, mean, median, mode are equal at this point. And what is skewness? Skewness measure the studies, the degree and the direction of departure from symmetry. So this is a symmetrical situation. This is a symmetrical situation. Okay, but if there is any kind of deviation, suppose the series is like that, okay, or the series is like that, series is like that, so that kind of departure is known as skewness. So I hope you would have understood this completely. A symmetrical system is a system in which we can write like this. So this is a complete symmetrical system. What is symmetrical system? A system in which the frequencies of items lies equally to either side, whether this is a left hand side or this is right hand side. Okay, so here has been given some values of x, there has been given frequencies. Okay, so 60 occur these many times, 62 occur these many times. So these kind of frequencies are there, and when we make their plotting, and if we reaches at the bell curve or the symmetry this is known as a normal curve or symmetric curve. Okay, but if there is any kind of departure, if the image is like that or image is like that, then these kind of systems are known as asymmetry, and there will be the prevalence of skewness. So this is skewness. Skewness simply means a departure from centrality. Departure from centrality. Centrality is here, this value. Okay. So I hope you would have understood. By this one example, I shall completely explain you each and everything about skewness and kurtosis. So a symmetrical distribution when presented on a graph gives a symmetrical curve. So this is a graph and this is giving us a symmetrical curve. Okay, where value of mean, median, mode are exactly equal. And on the other hand, in asymmetrical distribution, values of mean, median, mode are not equal. Okay, they are mean, median, and mode are never equal in case of asymmetrical distribution. What is asymmetric? These two are asymmetric distributions because the frequencies are not distributed equally to either side. Either this is left hand side or this is right hand side. Now, you would have understood this completely. How can you know? How can you know that there is skewness? How can you know there is skewness? Okay. So again, as usual, I have to tell you and I have to clear your mind. You are not supposed to go through from their numericals or practicals. All the formulas have already been given in the notes, and your purpose should be to clear your concepts only. If you wish to go through from the practicals, just one or two examples would be much more than enough. Otherwise, practical question is not being asked, not going to be asked from this specific topic. Okay. But concept clarity is must, because in the coming days we have to go through from probability distributions, and once we start probability distributions, the skewness and kurtosis are base of probability distributions only. This is the reason why I'm explaining you all these concepts very deeply. Okay, so let me show you this picture. This is a symmetrical distribution where mean, median, mode is equal. Okay, so this is asymmetrical distribution. These two are asymmetrical distribution in which mean is greater than median and median is greater than mode. So first of here shall come mean, then median, then mode. So mean is lying there, median is lying there, mode is lying there. So that kind of asymmetric distribution is known as positively skewed distribution. Okay. And in case the frequencies are tilted toward right hand side, then mode is greater than anything, then here comes the rule of median, then mean. Okay, that means mode is greater than median, then is greater than mean. So this kind of situation is known as a negatively skewed distribution. There are only three kinds of distributions. Okay, so first is symmetrical, the second is positively skewed, the third one is negatively skewed. I have written this here completely. When values of mean, median, and mode are equal, there is no skewness. This is a symmetrical distribution. When mean is greater than median is greater than mode, then skewness will be positive, and this situation is known as positively skewed distribution. And in case mean is lesser than median is lesser than mode, then this is a negatively skewed distribution. Only this one picture can make each and everything clear to you. Okay, so this is how you have to arrive at the conclusion of what skewness is about. So now we have to move further, as you have already known now, right now, that what's the meaning of skewness. Now you have to go how to find this. How to find this. Different authors have been given different formulas, but first of all, I have to explain you there are two versions of skewness and kurtosis as well. Okay, so what are these? Okay, when we study skewness graphically means presenting in a graph. Okay, presenting in a graph, we can find out whether skewness is positive or negative or zero. Zero means symmetrical, positive means mean is greater than everything, negative means mean is lesser than everything. And mathematically, it can be studied in two forms. I told you there are two versions. First is absolute skewness. Second is coefficient of skewness. That means if we are finding the value of skewness in positive terms, like skewness is point something or like that, okay? So this is absolute skewness. But if we are representing skewness in percentages or a ratio or proportion, these kind of expressions will known as a relative form of skewness. Okay, when skewness is presented in absolute terms, like 1.5, like this is absolute skewness. But when this is presented in a ratios or percentages, then this is a relative or coefficient of skewness. Okay, so relative measures of skewness is also called as coefficient skewness. Only these things you have to go through. Otherwise, there are number of details, but these are much more than sufficient. Now I shall tell you how to calculate skewness. I hope you would have understood about the basic of skewness. Skewness simply means a departure from symmetry. X is here, Y is here. Y stands for frequency, X stands for items. If you present these in the graph and if you receive bell curve, then this is a symmetrical distribution. And if this is tilted on left hand side much more than right hand side, then this is positive. And if this is tilted on this side, then this is negative. Okay, negative skewness. So these are the things. Now they have been most prominent economists who have given some formulas to find the skewness. Okay, this is Bowley's method, then Carl Pearson and Kelly's method. And I am 100% sure either you are student of commerce or from management background, you would have gone through in your studies from these three methods. Okay, now again you have to recall all these things. Otherwise, going through from their basic formulas and cramming these in the mind would be much more than enough. You are not supposed to solve practicals. One practical would be much more than enough. Okay, so this is practical are not going to be asked. Each and every formula regarding central tendency or dispersion or skewness has already been provided to you in the notes. So first of all, Bowley's, what does Bowley's method says? Bowley says skewness is always based on median, upper or lower quartiles. Okay, upper or lower quartiles. Quartiles you have to understand. Quartiles means when a series is divided into 4 parts. Okay, quartile 1, 2, 3 and 4 parts. Okay, so this is known as quartile. You would have gone through from the concept of a quartile, then decile, then percentile. Quartile converts the series into 4 parts, decile into 10 parts, percentile into 100 parts. Okay, so these parts, why we are not going through in depth of these things, the only reason is these have not specifically been written in our syllabus, and never in the history of examination the question has been asked from these parts. Only the subject matter would be necessary. Why? Because under Bowley's method, it's necessary to find quartiles as well. Okay, so now I shall explain you how to find absolute and a relative version of skewness from all the methods. So Bowley says when you make sum of a quartile 1 and quartile 3, and when you deduct 2 median from this, you shall get the value of skewness. This is very simple. Okay, so how to find a relative version as per Bowley's method? He has given this method. When you make sum of a quartile third with the quartile first and you reduce 2 median from that and you divide this all by quartile 3 and quartile 1, you shall get the value of a skewness in relative forms, means in percentage or a ratio. Okay, so this is how you should understand the concept of skewness from the point of view of Bowley. Okay, So only one line would be much more than enough. After that, you can remember this formula. This one line is Bowley's method of skewness is based on median and lower and upper quartile. That's much more than enough. Okay. And that you always know that a range is always between plus or minus 1. That you all know, because range or ratio or proportion is always between plus or minus 1. Okay. So they says that with the use of median and quartiles, you can find the value of skewness. Now we move further. Now we shall try to find what's the meaning of skewness as per Carl Pearson's method. This is also known as Pearsonian's coefficient of skewness. Okay, absolute and relative terms both have been given. This formula stands for absolute version and this stands for relative version. And they says skewness can be found on the basis of mean, mode, and standard deviation. This is very simple. So what's the difference? Bowley says skewness can be found on the basis of median, lower, and upper quartile. But Carl Pearson says that the value of skewness can be found with the value of mean, mode, and standard deviation. And how to find these? When you minus mode from mean and you divide this by standard deviation, that will be absolute value of skewness. And how to find coefficient value? Okay, coefficiented value. This is when you multiply this by 3 and median is subtracted from a mean and you divide this by standard deviation, you get the value of a relative version of skewness. So this is how the skewness is found on the basis of Carl Pearson's method. Only this line and the formula would be much more than sufficient. Okay, even for clearing the concept of a probability distribution. What is this line? Carl Pearson says that skewness can be found on the basis of mean, mode, and standard deviation. Okay, and that you all know, range always lies within 1 or 2. If I'm asking you how many percentage of marks did you get in your final examination, you will tell me 30%, 60%, 90%, 98%. You will never tell me 130%. Okay, so this is range and coefficient always lie between plus or minus 1. The last formula is Kelly's method. Okay, and they have given us very simple system. As I have told you that dispersion contains the range, then quartiles, then percentile, and then deciles as well. Okay, although we are not supposed to go in details, but we have to understand these at least. I have already explained you quartile distribute a series into 4 parts, then decile into 10 parts, then percentile into 100 parts. And what does Kelly says? Kelly says skewness can be found on the basis of decile and percentiles. Okay, decile and percentiles. And how to find these? This is very simple. So they have given two formulas for finding skewness. One on the basis of percentile and second on the basis of decile. On the basis of percentile, it has been written here like percentile 90 minus 2 percentile 50 plus percentile 10 divided by percentile 90 minus percentile 10. So in this way, you can find the value of skewness, which would be not relevant if you are solving practicals. And on the basis of deciles, decile 9 minus 2 multiplied by decile 5, then decile 1 is to be made plus in these all figure. Then you have to divide this whole by decile 9 minus decile 1. So in this way, you can find the value of skewness from the formulas given by different personalities. Only these 3 personalities were there for giving the concept of skewness. First was Bowley, then Carl Pearson, then Kelly. Bowley said on the basis of quartiles and median. Carl Pearson said on the basis of mean, mode, median, and standard deviation. Then Kelly says on the basis of decile and percentile, you can find the value of skewness. So this was all the concept regarding the skewness. Now we have to understand the concept of movements as well. Movements are very necessary and one of my favorite topic. Okay, at our time we studied this a lot, and even if you pursue further research, these kind of things are very necessary to go through. What are movements? On the basis of movements, the skewness and kurtosis can both be find out. Okay, so already we have studied Bowley's, Carl Pearson, and Kelly's method. But moments is also a method by which you can find the value of a skewness. Let me tell you what is moments. Okay, what's the meaning of moment? When you find a mean of a series. Okay, this is a series. Series has some items: 800, 820, 1040, 1100, 920, and 900. And mean is this. And after finding the mean, you find deviations. Okay, 800 minus 930, you get 130. Then 820 minus 930, you get 110. And in this way, you find the deviations. Okay, you find the deviations. And when you scale these deviations with different values, okay, like if I'm scaling the deviations 130, 110, 110 with value of 1. Okay, this, and after doing all these, when you sum for all these, when you make a total of all these, you shall get the value of moment 1. Moment 1. This is known as moment 1. Okay. So how to find moment 2? Moment 2 would be, if we are writing here the value of 2, and after finding the value of all, if we make the sum, this will be known as moment second. Okay, how to find moment third? This is very simple: 130, 110, 110, 170. And when you make its cube like this, 3, 3, 3, 3. Okay, and when you make sum of this, that will be the moment third. That will be the value of moment third. And how to find moment fourth? 130, 110, 110, 170. And when you put here the value of 4, and after finding the values of all, you make sum. In this way, you can find number of moments as you wish. Okay, so I have explained you clearly what the moment means to you. Okay, so we use Greek alphabets mu. This is how moments are denoted. Okay, usually we need to calculate first 4 moments only. I have already explained you how to calculate this. This is how to calculate one moment, moment second, moment third, and moment fourth. Only 4 moments are needed to find the value of a skewness and a kurtosis. Okay, and these are represented as mu1, mu2, mu3, and mu4. Okay, now I shall explain you how to calculate the value of skewness and kurtosis on the basis of moments. Okay, so we move further. This is for value of first moment, second moment, third, and fourth. I have already explained you. This is deviation from mean scaring. This is deviation for mean. Value would be third for scaring. Deviation from mean, this is fourth value. Okay, you can make fifth value, sixth value, seventh value. You can find as many moments as you want, but for finding the skewness and kurtosis, only 4 moments are necessary. Now let me tell you how to find skewness. For finding the skewness on the basis of moments, you have to find beta and gamma. Okay, so in statistics, we use the terms beta 1 and gamma 1 for skewness, and beta 2 and gamma 2 for kurtosis. Okay, so what is beta 1? Beta 1 is simply the value based on moments. Okay, moment third square, moment second cube. When you solve this, you shall get the value of beta 1. Okay, and this is your skewness. This is very simple, the value of skewness. So this is beta 1. And this is the first step or the first method for finding the skewness on the basis of moments. The second one is gamma. Okay, gamma, this is used for finding the coefficient of skewness. How? When you have already found the value of beta 1, you have to find its under root only. And when you find its under root, that shall be the value of a gamma 1. This is also the value of a skewness. The only difference is this is in absolute terms. This can be represented in absolute terms, and this can be represented in coefficient terms, okay, because there was some drawback which was erected by Carl Pearson by giving gamma 1. So I think you would have understood the concept of skewness on the basis of the moments. Now we have to understand about the kurtosis. I have already told you about skewness. Skewness. So first of all, you have to take this picture into your mind. Okay. So let me tell you what is kurtosis. On by seeing this picture, you shall get to know its complete meaning. I am going to explain you. So this we have already studied. Okay. Sometime the distribution can be less peaked. Sometime it can be normal. Sometime it can be more peaked. Less peaked or more peaked means this is flattered, okay, and this has higher levels. Okay, these are higher levels because this has more peakedness and this has less peakedness, and this is normal. This concept is known as kurtosis, finding how much a frequency distribution is peaked. So this is known as kurtosis. So kurtosis are of three types as have been written here. Okay, so we measures each divergence by index. Kurtosis refer to peakedness or flatness of a curve of a frequency distribution compared with the normal curve. Now let me tell you, if the curve is not very much peaked, this is known as a platykurtic. If this is normal distribution curve or mesokurtic. And if this has higher level of a peakedness, this is known as leptokurtic. Only these three things were there. And kurtosis is always find on the basis of moments. So leptokurtic means more peaked like this. Normal means mesokurtic, this value, this is normal distribution. Platykurtic means a flatter value or flatter distribution like this one. So this is about kurtosis. Now how to find that? I have already taught you that beta 2 and gamma 2 are used for finding the value of kurtosis. How to find these? You have to find the value of beta 2. This is moment fourth divided by moment second square. This will be the value of beta 2. Greater the value of beta, more beta 2, the value in the denominator, greater the value of beta 2, more peaked the distribution will be. More peaked means more peaked the distribution will be. So in this way, you have to understand this concept and how it is find on the basis of a gamma 2. When you minus 3 from the value of beta 2, then you shall get the value of gamma 2. And this is the second method for finding the valuation of coefficient of kurtosis. So all these things were there. First of all, you have to understand about the complete concept of skewness. Skewness simply means the frequency distribution flatterness. Like this is if you get the bell shape curved, when you write the frequencies for a specific values of or items, if you get bell shaped curve, this is symmetrical curve. And after that, if you get tilted on this hand side, then this will be positively skewed curve. And if you get the distribution tilted toward this side, this will be negatively skewed curve. Okay, terminologies I have already explained you completely. Then you have to understand about the different methods. That was Bowley, then Carl Pearson, then the last one was Kelly. Okay, then you have to understand about moments as well, moments from the mean. Then you have to understand about beta 1, beta 2, and gamma 1, gamma 2, beta 1, beta 2 are used for beta 1 and gamma 1 are used for skewness, beta 2, gamma 2 for kurtosis. Kurtosis simply means peakedness of the frequency distribution. If this is highly peaked, leptokurtic, then mesokurtic, then plateaukurtic. Okay, these things I wish to teach you. Each and everything has already been given in the notes as well. You can easily go through, because my purpose is to clear your concept so that it becomes easy for you to go through from the notes as to understand the concept and subject matter. As if the question is asked in the examination, then you shall be able to answer this completely. All the formulas have already been written, and I never suggest to go through from the practicals. Okay, Otherwise, if you don't obey me, you will waste your time. You should spend your time productively for solving mathematics operations and reasoning questions. Okay. To these, you can understand the formulas by going through from my video lectures once, twice, thrice, or number of times. Okay. So this was all about curtosis and skewness. I think you would have understood the concepts completely. The notes and the video lecture and the recording shall be provided to you in a very detailed manner. And some other videos are also being planned. In case of any still doubt, you can ask us. And I hope you are very regular. And only the regular students shall qualify this examination. Otherwise, you can't cover this examination in even 1 or 2 years. Okay. So whatever we are giving to you, you have to understand the basics and the concept matter in a very detailed manner. Whatever I am giving to you, you have to go through from the recorded and the live video lectures for number of times. Only then your concept shall be cleared. So about the next class, it shall be intimated to you the next day, that will be on Monday, and we shall give our best. There are some kind of a problem, a technical problem for the website. We are resolving is as soon as possible. Otherwise, I need your regularity. I can call you anytime and I can ask you about your preparations. Thank you so much for joining me for this lecture. This is Gurpal Singh from Gurpal Education.